Hello everyone, welcome to my channel. I'm Jacob. This is the Linux Cafe. I changed the name suddenly, and actually I lost my Telegram channel sadly. I don't know what to do. I actually sent an email to the Telegram support, but I know that it's not going to work, so because I actually lost my whole account and actually my Telegram channel, so I started a new one. And if you want, you can join. So Cafe Linux is the name of the Telegram channel, and the Linux Cafe is the ID of our YouTube channel. So welcome to my fifth video. In this video, we're going to talk about what actually are files in Linux. Actually, we hear this. Let me just minimize my recorder. Actually, we hear this sentence, this popular sentence that says everything in Linux is a file. So what does that mean? When you install Linux, you cannot find any drives on it. You cannot find the C drive or the D drive as you can find on Windows. So how does it work? How is Linux handling our disk, our drivers, our actually data? So Linux works with a bunch of files. Linux has a root tree, as I'm going to show you in this video, and I'm going to talk about the popular directories that you must know on a Linux system. So just let me stop my system upgrade because it's going to take a long time due to connection issues. So let me just increase my font, as always, clearing the screen. So you learned about the pwd command, print working directory, which is home taro, my username, true. So just let me cd into an upper directory. It's home, so pwd, we're in the slash home, true. So we're in the slash home. Where's a slash? So we can cd into slash, or we can cd dot dot to cd to the upper directory, which is slash. The name of the slash is root. So actually we're going to cd into root. So cd slash pwd. Now we're in slash. So if we just type cd upper, we're going nowhere because this is the upper directory and there's no more directories uh, beyond this directory. So we just say pwd and we see slash, which is root. So if I say ls, I see a bunch of directories here. True, bin, boot, cd-rom, dev, etc, home, lib64, last found, which is a special one, media, mnt, opt, and blah blah blah. So what are these? Actually, these are the directories that the whole system is around these files and directories. So each directory contains a bunch of files which are actually controlling our system. This is our system. If we delete root, as I told you, the special command sudo rm-rf/*. So this is going to say rm remove and -r recursively, and also force it to remove everything in root. So it removes everything in your system. If you run this command, you're going to ruin the system. You can actually test this command on a virtual machine and see what will happen. Let me check. Okay, so let's not run this command. So let me talk about these directories one by one, actually the important ones. So what is bin? Actually, bin is in light blue and it's a soft link to user bin. So let us cd into bin, as you can see, and as you can remember, because I told you that bin contains the binaries. Actually, bin stands for binaries in the system. So what are the binaries? The binaries are the applications, pre-built applications on your system which you're running daily. For example, ls is a application. Actually, we can write ls using C, or we can write commands for ourselves using C. And actually, after writing them and after building them, we can actually make a package and we can install that package on our system, so we can have a command easily, and that command can have a man file. in future videos, we're going to do this easily. So I'm in, you can see, let me cd, and if you press cd without actually any um, destination, it will just return you to the home directory, to home your user. So let me just write a C application. You can see app.c. Oh, I have the app.c here as a test. Let me just say vim, I don't know, hello.c. True. Let me write a simple C program so I can show you how these binaries are created. If you have coded in Python, you cannot actually handle this because Python it's not a compiled language, it's interpreter. So it just interprets every line on the fly when you run your program. But C, it's not like that. It compiles the whole program once and it creates a binary file which you can run that binary file as many times as you want, whenever you want, wherever you want. Okay, so just C. I can say printf, for example, of course, \n, and I can say hello world, true, semicolon, return 0, and we're done. So let's quit. Let's say gcc hello.c and run our program. You can see hello world, easy. And you can see that it's green. True, it's green, which means it's a executive file. It's an elf. Elf. You can see elf here. Executive Linux file. Easy. So now if I run a.out, which is actually assembler output, so we can just pass a flag, I can say hello.c-o, I don't know, LLLS, for example, as you can see. I just want to show you that that's just the name. So LLLS, if I run it, you can see hello world. So imagine that ls command is written like this using C or I don't know, another programming language perhaps, but that's in C. So we can run it. If we go to bin, we can see many of these files. They're all green, and the blue ones are soft links to a binary file, of course. So here you can find the ls command and whatever command that you're running on your Linux system. True? For example, zip, zforce. I don't know. We're going to talk about many commands in the future. I'm going to teach you how you can actually work with your disks, with your drivers, with your USB. You can mount it, unmount it, write on it, actually using fdisk, gdisk, and so on. So, for example, you can see the who am I here. Who am I? Who shows who is actually active right now on the server, and actually another command is w. W. It says that Taro is using TTY2 and the login is for actually 3 minutes past 9, and so on. And he's using the GNOME shell. Well, in bin you can see the binaries. In home, or let me talk about etc first. In etc, you can see the config files. What does that mean? For example, imagine I install something on my device, on my machine. For example, that thing is SSHD, okay? OpenSSH, sorry. That thing is OpenSSH. So OpenSSH has a bunch of config files which I can config as an administrator. True? Or something else then, for example, OpenSSH, I don't know, HTTP, or I don't know, Nginx, Apache, or whatever, Docker. Kubernetes, anything that I install on my system has a config file or many config files which I need to work with them to actually write my rules, write my queries, and whatever I want to do. So they exist in etc. In etc, you can file the config files of the services you're running and whatever. True? For example, network. I can see the into network, if down, if post down, if pre-op. These are many directories with some files exist in them, and actually you can manipulate the files as you want. For example, in this file, you can find the shadow file. Let me show you. ls shadow. Shadow is a file. I can less shadow, permission denied, so we're going to say sudo less shadow. Let me open it. Shadow. So in shadow file, you can see the users. For example, here you can find me. Let me show you me. Yeah, that's me. That's me. This is my password. Shadow file holds the user and the password. True. And also we have the passwd file. So we can say sudo passwd. This one shows the user, if the user is active or not, the user ID, the group of the ID of the user, the group of the user, and where the user lives. It lives in home Taroch, and which shell is the user using. So if the user does not need a shell, so you can see it's nor it's neither it's either no login or false. True. So if the user is using something, it's bin bash on the system. So Tarok is using bin bash. So this is about etc. etc holds the config files. What about dev? So cd into dev. Dev is the short of devices. So here I can probably find my SSD drives. SSD hard, I meant. So let me just show you. Yeah, this is my NVMe, which is running Windows NVMe. And of course, I have the SSD, SDA, SDA part 1, SDA part 2. This means that this disk has two partitions. It's SDA, okay, so the first partition is SDA 1 and the second is SDA 2. Now, if we have another SSD plugged into the device. So it is going to be like SDB, and it will show the partitions of SDB like SDB1, SDB2, SDB3, and so on. True. And the second and the third device is going to be SDC, SDD, like this, you know. So in dev you can find your devices. So if I now right now just plug in a USB to my machine, I can see that like SDB. Let me just check if I have any USB here so I can show you fast. True. Yes, I have a USB here. Let me just plug it in. The device. You heard the sound. Now if I say ls, I can say SDB here. SDB, SDB1, because this disk has only one partition. And there's a nice command on Linux called lsblock, which shows the block files which you can find on dev. So lsblock says that here I have SDA1, SDA2. SDA1 runs my boot EFI, which is my Linux. So SDB is the USB, which is mounted in media and my user. I will show you how to create actually these directories and how you can mount your devices automatically on a Linux system in the future videos. So let's go to the upper directory. We have lib, which holds the libraries, and lib64 for a 64-bit system. The libraries exist there, so you can say lib64. It holds the LD Linux, and it shows the library. This is the library name. This is the architecture. This means it's a shared object, and the last section is the version of it, if you're curious to know. Lib. So I have a bunch of shared objects in this directory, as you can see. Okay, another important directory which you must know as a basic Linux user is the var directory. Var shows you the variables. So variables means they actually vary time by time. So what is variable? What is variable? It's, for example, your log files. If you're searching for a log file, you're going to check the var log easily. So there's a log directory here. The boot log, for example, or the dpkg log, the dmesg actually file exists here. So, for example, the dmesg command, operation not permitted, sorry, so sudo dmesg, it shows the log, your system log. Okay, so it reads the dmesg file and shows you the log of that file here, so you can read. Instead of opening that file, you can call this dmesg, and it shows you uh, colorfully what's going on your system. So, for example, here you can see, check this log, SDB, attached SCSI removable disk. You see, this is the log. Here it shows that I've attached or I've plugged in my USB. So this is about var. You can find logs here. And the last ones for this video are media and MNT. So for example, as you can see, if I seed into media, I have Taro here, and this is my USB. Now I'm inside my USB. Actually, I can create a file here. So touch something through. And now, if you check here, there's something here. I just create a file on my actually USB device. So in the next videos, I'm going to show you how you can create a directory and how you can mount your USB to that directory, and then you can check your USB files and change them and actually play with your USB device. So actually I'm going to clarify for you what is the action of mounting and what's the need for mounting. Because on Windows you just plug in your USB and you use it, but on Linux systems, not on all of them, but some of them you need to use the mount and umount commands to work with your disks. So that's all about this video. We talked about uh, actually some directories on the Linux system and what they do, what things they hold, so you can understand the sentence that says that everything on Linux is a file. So on Linux, we control many things with files. Everything uh, works in a file. For example, config files, you change config files and kernel reads that file and understands what it has to do. So that's about this video. I hope you like it. And in the next videos, we're going to talk about mounting and non-mounting. We're going to talk about fdisk, partitioning, actually drives, and many more things, many more commands on Linux. I hope you like the video. Thanks for watching. It was Jacob, Cafe Linux, new name for my channel for the rest of our life. See you soon. Goodbye.